So for this section, we will encounter some equations that have solutions that don't end up working out when we insert them back into the original equation. The title of this section is called Extraneous Solutions, and extraneous just means extra. It means things that we don't actually um, don't actually check out in the end. So the equation that we have below, if we're going to solve an equation with a square root that contains a variable, we need to square both sides. So the first step is to square the radical and square the right side. And so we would end up with 2x plus 3 with no root on it, and we'd have x squared. So now we have a quadratic. And what we know about quadratics that have both x squared and x is that we need to gather everything on one side. So we gather everything on the right side. Check to see if it's factorable. That's always the fastest way. And this one is. So when we factor it, we have x minus 3 and x plus 1. And that leaves us with two answers. We would have x equals 3 and x equals negative 1. So fairly simple way to solve that equation once we eliminate the square root. Now, since it's been solved algebraically, let's check those answers. If I put a 3 back into the original problem and a negative 1 back into the original problem, they would look like this. So 2 times 3 plus 3 would give me 9. Square root is 3. 2 times negative 1 is negative 2 plus 3 is 1, and that gives me negative 1. So does it work out? Well, in the first case it does, but in the second case, square root of 1 does not actually equal negative 1. It equals positive 1. So we know that one of the solutions is fine and the other one is what's called extraneous because it does not work out when we go back to check it. All right, so if we check these solutions graphically, what happens? Well, let's just graph both. So I graph a straight line at y equals x. So that's the right side of my equation, y equals x. And then the left side of my equation, square root of 2x plus 3. I used my x column in a way that would give me some easily calculated numbers on the square root. So I wanted that square root to come out to 0 first. So then I put in a negative 3 halves. Negative 3 halves times 2 would be negative 3 plus 3 equals 0. So that's my first x value. Then I wanted y to equal 1 and 2 and 3, and so I inserted x's for those too. So graphing that gave me my typical half parabola on its side. And you can see that it does cross the line at 3, 3, which we knew because when we inserted 3 for x, we got 3 for y, and that checked out. But what we don't see is inserting negative 1 for x. And if you can see this negative 1 line on my graph, had I continued that parabola down the other side, then it would have crossed here at negative 1. It would have been negative 1, negative 1. But because we don't have that second half in the square root function, that's considered an extraneous solution. So we can see it algebraically by plugging it in and not getting an answer. We can see it graphically because it's only half of a parabola and doesn't have a second intersection. Okay, so in the extraneous solutions section here to fill these blanks in, sometimes when you are solving radical equations, you will get an extraneous solution. So that's an extra solution. When you check it, it does not make a true statement. A solution is not a solution. So even though it comes out mathematically the first time, it doesn't actually count as a solution to the problem. So we have to check all answers for any radical equation that we do. So we'll solve the radical equation like we know how. We'll go back and check it to make sure that we actually did it right, or that both answers qualify. Okay, so let's go through these examples step by step. So if you want to pause and try them, you can certainly go as far as you want to. I'm going to show you step by step so you can then check against that. So graph algebraically first. If I were to try to solve this, I need to isolate my square root. So my first step is to add 1 to both sides. At that point, I'm ready to square, and that means squaring a binomial. So I'm taking x plus 1 and multiplying it by another x plus 1. Let's just be careful of that step. So at this point, I have x squareds and x's throughout the equation. I need to gather everything on one side. So adding x gives me 3x, subtracting 5 gives me negative 4. This is a factorable equation. And so then when I go to solve it, I would have a negative 4 and a positive 1. Now I've got this crossed out because what you'll see here is I'm checking both. When I insert a negative 4, I get 9. Square root of 9 is 3. 3 minus 1 is 2, not negative 4. So That one did not work out. On the other side, though, when I insert an x equals 1, then I get 4. So square root of 4 is 2. 2 minus 1 is, in fact, 1. So it worked for one. It did not work for the other. So that means I'm going to go back to my solution set and cross out the one that did not check out. Negative 4 is considered extraneous, so there's only one true answer to this equation. All right, example 2. So I need to, this is already set up to square. I can just go with it, right? So I can square the square root, square the right side as well. X plus 5 gets multiplied by itself. Move everything to one side. Subtracting 1x gives me 9x. Subtracting 7 gives me 18. Again, try to factor it if you can. This one will. 6 and 3. So I get negative 6 and negative 3. And we don't want to just assume that all negative answers are extraneous. That's not how it works. You do need to try them both and make sure. So when I insert a negative 6, I get 1 as a result, but it's supposed to equal negative 6 plus 5, which is negative 1, and that does not check out. When I insert a negative 3, I get 4 underneath the root, which comes out to 2, and then on the other side, negative 3 plus 5 does equal 2 as well. So the negative 3 solution is good. We circle it. The negative 6 solution is not. So you can use these notes as you're working through your classwork. But every time you see a radical in an equation, you square it to solve. Let's check for extraneous solutions.